everyone and welcome back to Measy Science channel. This is Safwan and Fallato. In today's video we are going to learn how to solve the particular integrals for the non-homogeneous differential equations. So don't forget to subscribe, like and hit the bell icon so that you don't miss out our future videos. So let's get started.
The solution of a non-homogeneous differential equation consists of two parts, the complementary function and the particular integral. So in the previous video we have learned how to get the solution of the complementary function, and now we are going to learn that of the particular integral. So suppose we are having a non-homogeneous differential equation f of d times y is equals to capital X, where f of d is the same thing as this equation over here, which is a second order homogeneous differential equation if it equals to 0, but since it is equals to x here, then it is a non-homogeneous differential equation, and capital X is a function of a small x. Then the particular integral from this equation can be written as this, where this is the function of x. So there are different rules depending on the value of the capital X here. So the first rule is when x is an exponential function, then the particular integral will take this form, where a here is a constant value, and then in order to get the particular integral, then we have to substitute for d is equals to a and then work out this equation over here. And if f of a here is equals to 0 in the denominator, that means the equation is an undefined equation, and therefore we have to apply the case of failure, which is multiplying x by this and then taking the first derivative of f of d, and then we substitute again f prime of a to be equals to a, and if it is 0, then we have to apply the same case of failure, which is multiplying x and then taking the derivative of f prime of d here. In this case, that is the second derivative. But if it is not equals to 0, then we proceed with the solution of the equation. The second rule is that when x is a trig function, maybe cos ax or sin ax, where a is also a constant, then in this case we are interested in the d squared value, and then the particular integral will be 1 all over phi of d squared multiplied by the trig function. And here
Problem number 1 says solve for the pi in this equation. So first of all, from this we know that this is an exponential function, and the solution for the pi is 1 all over f of d multiplied by x. So since x here is exponential minus 3x, then that implies that the pi will be f of d is this term here, 1 all over d squared plus 5d plus 6 multiplied by exponential minus of 3x. So now here, according to the first rule, we have to put d to be equals to a, which is 3 minus 3. So that implies that the pi will be 1 all over minus 3 squared is 9 plus minus 3 times 5 minus 15 plus 6 exponential minus of 3x. So 9 minus 15 plus 6 is 0. So we can see that the case fails. Here f of a is equals to 0. So now we have to apply the case of failure, whereby we multiply this by x and take the derivative of this. For the case of failure, the pi will be x multiplied by 1 divided by, then the derivative of this equation here is 2d plus 5, and the derivative of a constant value is 0, then multiplied by the function as it is, and then simplifying this we will have x to the plus 5 exponential minus of 3x, and putting d to be equals to minus 3, the pi will be x minus 3 times 2 minus 6 plus 5 exponential minus of 3x, which is minus x exponential minus of 3x, which is the solution for the particular integral.
For every d squared, we are going to substitute minus of a squared and then work out the equation. If it is not equals to 0, then the solution of this will be the particular integral, and if it is equals to 0, then we multiply x here and then we take the derivative of this with respect to d and then multiply by the function as it is and then work it out. If it is equals to 0, then we also have to multiply by x and then take the derivative of this and proceed with the solution of the equation. And the third case is when x is a polynomial such that x is equals to x to the power of m. Then here we have to use the binomial expansion of 1 plus u or 1 minus u in order to solve this particular integral. And here we have to make 1 all over f of d to be in form of either 1 plus u or 1 minus u, and then use these expansions in order to simplify the particular integral.
The second problem, for this type of problem where x is equals to a constant value, we can also apply the first rule here by including an exponential time. So we know that the pi is 1 all over f of d multiplied by x, so is 1 all over d squared plus 4d plus 4 multiplied by 7. So now in order to use the exponential function, we multiply the constant by 1 and then we can include an exponential term to the power of 0. So 7 exponential 0x. So exponential of 0 multiplied by x is 1, and 1 multiplied by this equation changes nothing. So here that implies that a is equals to 0. So now we put d to be equals to 0 and simplify, then the particular integral will be 1 all over 0 squared 0 plus 4 times 0 0 plus 4, then multiplied by 7, and this is 7 over 4, which is the particular integral for this non-homogeneous differential equation. So example number 3 is in terms of a trig function, and this equation can be written as d squared plus 2d plus 10 is equals to minus 37 sine 3x, and we know that the particular integral can be written as 1 all over f of d multiplied by x, and this is 1 all divided by d squared plus 2d plus 10 multiplied by minus 37 sine of 3x. So by the virtue of rule number 2 for trig, we substitute d squared to be equals to minus of a squared, not a all squared, and this is the same thing as minus 3 squared, which is minus of 9. So substituting that, then the particular integral will be 1 all over minus 9 plus 2d plus 10, then minus 37 sine of 3x, and this is 1 all over 1 plus 2d 37, and then sine of 3x. So taking the conjugate, this can be written as minus 37 sine of 3x 1 plus 2d, then 1 minus 2d, 1 minus 2d, and then the particular integral will be minus 37 sine of 3x into 1 minus 2d, all divided by 1 minus 4d squared. So here, since we are having d squared again, so we have to put d squared to be equals to minus 9 again, and then the pi will be minus 37 sine of 3x 1 minus 2d, 1 minus 4 times 9, that is 1 plus 36, minus, and this minus is plus, 4 times 9 is 36, and then this is the same thing as 37 divided by 37. We have this minus here, then sine of 3x all into 1 minus 2d. So that implies that the particular integral is equals to minus sine of 3x, then minus minus plus 2d sine of 3x. But it is known that d is the same thing as d dx. So that implies that the pi will be minus sine of 3x plus 2. The derivative of sine of 3x is 3 cos x, and then the pi will be 6 cos of 3x, 6 cos of 3x minus sine of 3x, which is the solution for the particular integral. So problem number 4, here capital X is a polynomial, and that implies that we have to use the third rule. So the pi can be written as 1 all divided by d squared plus 5d plus 6, then multiplied by x. So now in this type of problem, we have to make this in terms of 1 plus u to the power of minus 1 or 1 minus u to the power of minus 1. So for that, we have to take the inverse of this, and that will be this all to the power of minus 1 multiplied by x. And for us to get this to be in terms of 1 plus u, then we have to factorize a constant, which is 6 in this case, all into d squared plus 5d divided by 6 plus 1. So when we expand this 6 will cancel this 6, then we'll have d squared plus 5d, and then 6 times 1 is equals to 6, all to the power of minus 1 multiplied by x squared. So here factorizing 6 to the power of minus 1 will be 1 all over 6, all into 1 plus d squared plus 5d all over 6, all to the power of minus 1 multiplied by x. So this is in terms of 1 plus all this value is our u. And recalling that the expansion of 1 plus u to the power of minus 1 is equals to 1 minus u plus u squared minus u cubed plus other higher powers of u. And here our u is d squared plus 5d all over 6, and the highest power of our polynomial is to the power of 2. So therefore in this expansion we have to stop at the second power of u. So that implies that the particular integral will be 1 all over 6 all in 1 minus of u, which is d squared plus 5d all over 6, then plus u squared plus d squared plus 5d all over 6 squared minus times x squared, since the highest power here is to the power of 2. So simplifying this further, we have 1 over 6 all into 1 minus d squared plus 5d all over 6, then plus expanding this, we have d to the power of 4 plus 10d cube plus 25d squared, all divided by 36 minus this times x squared. And it is known that d of square x is dx over dx of s squared. So this is the same thing as 2x, and d squared of x squared is the same thing as d squared dx squared of x squared, which is equals to 2. So higher derivatives of x squared are all equals to 0 since the second derivative is 2. So substituting all these values here, we will have the pi will be equals to 1 divided by 6 into 1 minus, first of all 1 multiplied by x squared is x squared, then minus d squared x squared plus 5d x squared all over 6, then plus b to the power of 4 x squared plus 10d cubed x squared plus 25d squared x squared all over 36 minus dash. Okay, so right now we have to substitute the first derivative, second, third, and fourth are all equals to 0. Then the particular integral will be 1 over 6, all into x squared minus d square x squared is 2 plus 5 times first derivative of x squared is 2x all over 6 plus this is 0 and this is 0 because this is third derivative, which is 0, fourth derivative is also 0. Then 25 times second derivative of x squared is 2 all over 36. Okay, so that's it for today's video. I hope it was useful for you people, and if you have any problem in concepts of physics or mathematics, you can drop a comment below and we'll try our best to make that video for you. Thank you for watching and see you next time. So simplifying this further gives 1 all over x squared minus 2 times 2x, minus 2 all over 6, then minus 5 times 10x all over 6 plus 50 divided by 36. So this is 1 over 6 all into x squared minus 1 over 3 minus 10x over 6 plus 50 over 36, and then this is the same thing as 1 all over 6 x squared minus 1 over 3, 2 here, 5, 2 here, 3 x plus 25 over 18. So taking the LCM of this and this gives 1 over 6 x squared. The LCM is 18 minus 18 here 6 times 1 minus 6, we have minus 6 plus 25, then minus 5 over 3 of x, and this is 1 over 6 x squared plus 19 over 18 minus 5 over 3 of x, and this is the particular integral. Okay, so that's it for today's video. I hope it was useful for you people, and if you have any problem in concepts of physics or mathematics, you can drop a comment below and we'll try our best to make that video for you. Thank you for watching and see you next time.